Hello there. Now that you've mastered solving linear systems of 2 equations, 2 unknowns, we're going to look at one with 3 equations, 3 unknowns, talk about the underlying strategy, and then how you can extend that for 4 equations, 4 unknowns, so on and so forth. So first thing we'll do is label what these equations are. Equations 1, 2, and 3, and now I'm going to look for making a meaningful combination that begins to eliminate a variable. So I could look through here at the x's and scale by -2 to combine equations 1 and 2. But actually, the way that these are set up, I could multiply through and get them to cancel easier, because one's positive, one's negative. So I'm going to do that. Please label your operations. I'm going to take equation 1, this whole thing, and scale that whole thing by 3, and then copy down equation 2 again to get my y's to cancel. Have to make sure that this 3 gets distributed to each and every term along the way. It's very easy to forget one particularly at the end, and now I always set these up with one positive, one negative, so I can cancel with addition. And I've created a new equation. Oh, this one's kind of nice. I could actually reduce it. I'm not going to. I do, however, give it a name. This is equation 4. And at this point, I'm going to stop with this combination, go back up to the drawing board, and look for how I could eliminate something else. Now, I could eliminate the z's here, scaling by 5, but then I would have an equation here, equation 4, with x and z, and a combination of 2 and 3 with x and y, and I would have 2 equations, but I would still have x, y, z, 3 unknowns, and that's not in my favor. So if I started with eliminating y's, I need to continue to eliminate y's, but I need a different combination. I already did 1 and 2, so now I'm going to do 1 and 3. We're going to double equation 1, so we get 2y to line up with the negative 2y. Okay, distribute through to everything. The y's are lined up, one positive, one negative, and I can cancel with addition. We've created a new equation, so let's give it a name. 5, equation 5. So the way I've gone about doing this problem, I chose to eliminate y's, and I've got down to this equation, and they both only have x and z in them, so I have 2 equations and only 2 unknowns, and I know how to solve a problem like this. Of my options, the x's don't look like good candidates. Let's go with z's, scaling equation 5 by -10. Z's are lined up, one positive, one negative, cancel with addition. And at this point, I can just divide by -60. So this all unraveled, and x is equal to 3. Now I'm going to ride this back up one step to go into one of these 2 equations. Actually, let's go with this equation. So I could go with one of these 2. I'm going to go back up to equation 4. Actually, equation 5 is nicer. So I'm going to write it up to equation 5, plugging in a 3 for the x. So there's my copy down equation 5. X is being replaced with a 3, multiply through, and subtract to get your z. I now have 2 of the 3 unknowns, so I wrote it back up to equation 5. Now I'm going to write it back up to one of the original 3, and equation 1 actually looks like the best candidate here. Plug in those values for x and z. Expand things out, gathering like terms, and solve for y. At this point we have the x value, the y value, and the z value, so let's write them together for our solution in Victory Purple. Double check by plugging those values 3, 4, 5 into the original equations 1 and 2. We know that equation 1 already works because that's how we got this one over here. So double check up here, see that it works out, and we are done. Character and Scholarship for Life.